This video we're going to look at structural steel erection, sort of putting the steel structure together. So the first step is to take the steel members that have been fabricated in a workshop and put them on a truck and take them to site. So the limit for in New Zealand is a 15 metre length and a 2.5 metre wide load. After that it's oversized and you need a special permit, and things just get that a little bit harder. So it's easier to just fabricate the components into sections that do not exceed 15 meters in length, and then join them on site if they're any longer than that. The load needs to be secured, and you need to think about unloading it. So on site, if there's a high-ab on the truck, which there's a high-ab there, so you can see that that's a little crane there which sits on the truck, so this truck can unload itself. If the truck doesn't have a high-ab or a crane on it, you need to have a crane or an excavator on site that can lift the steel off. The steel is too heavy for people to actually lift. The storage, the steel needs to be stored straight on timber spaces. You don't just drop it on the ground, you have timber on the ground and the steel sits on top of it. So it can deform, so you need regular supports along the way. And if there's a surface coating on it, you need to protect it from scratching. So oftentimes you'll see them arrive on site wrapped in plastic packaging. Now you can see here they've got what looks like could be columns. So there's the column, the I-beam, and then they've got the plates sort of welded onto the end already coming to site. Actually these could be beams. You can see they've got stiffening plates sort of welded in already. So it's all delivered to site, ready to be just lowered into place and constructed. So if you've got an oversized traffic transportation, then you have to have someone at the front, drive a pilot vehicle at the front, pilot vehicle at the back. So it turns into a bit of a nightmare. But obviously if you've got things of this size that have to go into the structure, then there's no avoiding it. You have to go with that heavy load precautions. So the steel storage on site, as I said, it needs to be stored flat, it needs to be sitting above the ground so it's not sitting in water and rusting, and it needs to be regularly supported, so you can see that they've got the timber underneath it. You can see these guys here, they've just lifted it into place. They're actually just moving those around, and they were using this crane here, and so you can see they're just taking the strops off now. You can see that it's all welded up. It's got the little plates on it for the purlins, and it's got the plate there to connect to the column. And here's another set of steel stored as well. So the steel building erection. The usual method is the steel components are fabricated at a factory, transported unconnected, connected on site. And so now we're going to look at the rate. How fast does it take to put it together? And it comes down to the simplicity of the connections. How many bolts are there? If you're doing welding, it's going to take longer to make the connection than it is to connect the bolts. You have to get the welding machine onto up to the level. The guy has to set it all up. It's much faster to actually bolt it, but sometimes you do need a welded connection. How many members there are? How much can you do on the ground? Can you actually put some of the members together on the ground? And that comes down to the shape of the members and also the lifting capacity of the crane. So the type of the connection, the worker experience, and the materials that they're being delivered at the right times. So the erection methods, connection at the ground level, as I said, it's safer, there's less work at height, it's quicker, it requires a bigger crane. So you're looking at how heavy is this thing when it's all put together, and what is my crane capacity. Or connection in place, you lift it into place. Remember, you're usually doing that at height, 5-10 meters above the ground, and it's harder to make connections because you're sort of trying to keep yourself safe. You're at height, it's often windy, and usually you have to use lighter components. So here's an on-site bolted connection. Here's a rigger, that's what the people are normally called, and he's got in his hand there a podger, so that's what a podger is. And so what it's got is two ends. So the first end there is a spike, and that spike they put it through when the bit of steel comes close to the hole. They put it through both holes and they align them using the drift pin there. And then once they got it aligned, then they put the bolt through, and they use the spanner head to tighten it up. So it's one instrument doing two very important things: aligning the holes between the beams and the columns, and then tightening the bolts when you put them in. So he's got all his bolts and his nuts sitting in his tool belt there. So you place the nuts and bolts loosely. You line them all up and then put the one diagonally opposite. Then you put all the rest of the nuts and bolts in, and then you make sure that the structure is plumbed, square and level, and then you tighten them in a sequence. So normally it's you go from tighten one bolt, then you go diagonally opposite that, tighten that one, do one bolt, then diagonally opposite. So you don't tighten them round like a clock. You actually tighten them in diagonal shape, and that means that you're actually going to get the whole thing sitting flat. If you just did one side and then the other side, it's likely that it's going to be skew whipped because you've tightened one side already, and the plate's going to lift off the support just a little bit, and it's going to be very hard to sort of get it back down again. So you normally tighten direct in a diagonal shape, diagonal direction. On-site welding. So sometimes you do have to do it. So on-site welding. So this doesn't look very safe. I'm not even sure if he's got a harness on. So I'm pretty sure that is sort of how not to do it. You can see that he's got his cherry picker there, and he's got his equipment on top of that. So he's had to get it up to level. I'm pretty sure this would fail most health and safety sort of things. So talking about safety, falls are one of the main issues we have in New Zealand, and so we're going to try to carry out as much work as we can on the ground. The workers need to wear harnesses, unlike the fella in the one before. Use cherry pickers and other access devices so that they're working from a stable platform. Safety handrails and specialist training. So let's look at vertical access. How do you get up to 5-10 meters and work safely? And so this thing here is called a cherry picker. So you can see it's got wheels there, it's got a little lifting thing, and it's got an arm, and on the end it's got a little a working platform. And so these ones here, notice that they're not driven from the ground, they're driven from up there. So the person sits up there and they can drive these things forward and back and turn them and all that sort of business. So they get themselves into position, they can lift themselves up, lift themselves down. So you can see there's two of them, so there's one either end of the beam. So it's usually 2-3 person job, plus the crane. So one person at one end, one person at the other end. You drop it into place with the crane, you both bolt up your particular connections. So here's another version of the not a cherry picker, a scissor lift. So instead of having an arm, hydraulically activated arm, you've got one hydraulic thing there, and it just lifts it up and lifts it down. It's not as versatile as one of these cherry pickers, but a little bit more stable. So another way of providing access, or a more permanent temporary solution if you like, is scaffolding. So you build scaffold on the sides. Now that would only really be justified if you had quite a lot of work to do in that particular area there. If it's just a one connection, like if you're just putting beams onto columns, scaffolding wouldn't really be justified. It takes quite a long time to set it up, and it's a lot more costly than using a cherry picker. But if you've sort of got a lot of work to do, or you might be sort of on a wall, so you're putting the beams on top of a wall there with columns down either side, and then you need the scaffolding later on for them to hang wall panels on the whole thing. So it might be justified to have scaffolding when you've got to hang wall panels or something like that later on. So cranes are another way of access. So you've got mobile cranes, and you can see this one here. So they travel on the road, come to site. The crane arm, the boom, compresses back into or folds back into that one beam there. So you can actually extend it up quite high. You've got tower cranes. So for big high-rise buildings, you normally build a tower crane there. There's different types of tower cranes. So you can see this is a different type from that. And here's a big mobile one. You don't see these very often, but they are heavy lift mobile cranes, so they can move along the site as well. So just looking at tower cranes, You got the hammerhead and the luffing boom. So those two different shapes there. They do the same thing. The luffing boom just is a little bit takes a little bit more time, but it's a bit cheaper to put up. This one here, it's just a matter of sort of lifting and putting it back, lifting it, moving it to the position, and then dropping it down. With this one here, you're always lifting the boom up, lifting it down to sort of to get it into position. So they're static, they're built on site. As they go, you can actually add more sections to it, so that both cranes can actually be lifted as the building goes up. You've got the operator cab sitting in the top there, so the operator's got pretty good view over the whole site. Yeah, and that one there, they've got it too. So at the crane is powered by a motor, which is sort of usually at this end here. So you have the motor and the counterweight there, sort of like a seesaw, counteracting the weight of the load on the jib, the boom. Same here, you've got your motor and machine and a counterweight providing a counterweight to the load on the boom. So mobile cranes, you've got crawlers. You can sort of have them mounted on tracks, or you can have them on wheels. So this is not so common anymore. These telescoping boom trucks, they are quite common now. That type there is quite common. They can be operated from within a cab, or they can be operated from the side of it. So the trick is to make sure that the load, that the extension of the arm does not exceed the load. So as you're closer into the truck, you can actually lift more load than if you're further away, and so that needs to be considered. And so there are crane tables that you need to be looking at to figure out what the safe lifting distances and loads are for a particular crane truck.